Good morning, everyone. And so we are going to continue with our solving the equation. Today, our focus will be on quadratic equation. So, for example, let's say this question is given to us. They said x raised to the power of 2 plus 8x minus 9 equals to 0. And they asked us to solve this. Solve the equation. They asked us to solve this. Then we have three methods that we can use to solve this quadratic equation, and we will look at all of them. Remember, this is just a refresher course that I think is necessary. Some people don't have adequate maths background from high school or from where they are coming from. We can use factorization. We can also use completing the square. Completing the square method. Completing the square. We can use the quadratic formula, the general quadratic formula. Remember, sometimes this one also it's called a simple quadratic formula. Simple quadratic formula. So we have these three methods that we can use to solve this quadratic equation. We will use all of them to solve this. And we know the formula for completing the square is very straightforward. It's very straightforward. That is x. We have seen this already in our previous lectures. X equals to minus p over 2 plus or minus in square root p square over 4 minus q. For the general quadratic formula, the formula is this: x equals to minus b plus or minus in square root is b raised to this minus 4ac all over 2a. Now we have this already. The problem with factorization is that it doesn't work all the time. Not all quadratic equation can be factored. So it doesn't work all the time. That's the shortcoming. It doesn't work all the time. But the basic concept is there. So we will look at all these methods to find. And here also, we have to know how to derivation, how to drive these formulas. We will look at them, derivation of them, which is key. It's not enough to memorize the formula, but we should know how to drive them, how they came about. We will also look at the derivation of this. Look at this. So let's solve this equation, trying to use factorization, completing the square and the quadratic methods. So we start with the factorization. So let's start with factorization. So let's look at factorization method to solve what? This quadratic x raised to the power of 2 x squared plus 8x minus 9 equals to 0. So when we talk about factorization, first thing what you need to focus on is these 2 and this one minus 9. So for here, we have to find two variables that if we multiply, we will have x square. And obviously the two candidates are x times x. So x times x will give us what? X square. This square is which is this one. So here also, we looked at two numbers. When we multiply, it will give us minus 9. But if we add those two numbers, they should give us what? Plus 8. They should give us plus 8. So the two numbers that when we multiply, they will give us minus 9. And when we add them, it will give us plus 8 is what? Is plus 9 times minus 1. So it will be 9, that is plus 9 times minus 1. This will give us minus 9. But remember, if you add these two, that is plus 9 minus 1 should give us plus 8. And this plus 8 here is what we have here. So we have factorized this. This is what we mean by factorization. Use factorization to solve this quadratic equation. So after doing this, we just have to collect these factors then we collect this one also. So we will have x plus, is x plus 9 in bracket, multiply by what? X minus this one. This x, we bring it here, then minus 1 here, equals to 0. If you expand this, it should give you what? X raised to the power of 2 plus 8x minus 9 equals to 0. So by factorization, what it means is to simplify this, and it's what we did here. So equivalently, we will have x plus 9 equals to 0, or x minus 1 in bracket equals to 0. Remember, we are trying to solve. They said, well, we solve this equation. Solve it. Sorry, this should be, so let's even go further. Let's just say solve the equation. So the task was to solve this equation, and solving equation, we have talked about it. It's about finding the value of the variable. That is what is x. And when we talk about quadratic equation, it always has two solutions. That you must have x, 2x. You know, sometimes it can have one solution as well. You can have it whereby the discriminant is equals to 0, but we will check those things later. So what we are trying to do here, x plus 9 equals to 0, or x minus 1 equals to 0. We want to find the value of x. This is what we are interested in. This is what we are interested in, and to do that is simple. It will be x, this one will come here, it will be x equals to minus 9. We can call this x1, or x equals to 1. So we can call this x2. So we have the solution. This is the solution. Now it is solved by using factorization. And as I mentioned before, factorization doesn't work all the time. So in case you cannot do factorization with quadratic equation, you have to use the completing the square or the general quadratic formula. They always work. So let's go and look at the quadratic formula. Let's solve the same equation using the completing the square. So B, let's look at what? Completing the square method. Completing square method. So we want to use this to solve this equation, x raised to the power of 2 plus 8x minus 9 equals to 0. So after having your equation, the first thing that you should write is the formula. And the formula says what? If we want to find the value of x here, we can use this formula, which equals to minus p over 2 plus or minus in bracket equals to p raised to the power of 2 over 4 minus q. Obviously, what we need to do here is to know what is p and q. if we know what is P and Q, then we can substitute it in it. But if you remember, we know P is calculated as what? B over A. And Q is calculated as what? C over A. So we need to know what is A, what is B, and what is C. And that can be found in the quadratic equation. So we have our A as what? A is what? Is the coefficient of the quadratic term in quadratic equation. So we don't have anything written here, but we always assume it's 1 when there is nothing written there. So this will be 1. So then B is what? B is the coefficient of the linear component, which is 8 or plus 8. And C is the constant, which is minus 9. So we are going to calculate the value of P, and we said P is what? We have this, we have this. And we said P is what? B over A, and B is what? 8, and this will give us 8. And we will calculate Q, and we calculated it as what? C over A, and C is minus 9 over 1. And this will give us minus 9. So we have to go on and substitute this 8 into here. Yeah. And the P is the same. We put 8 there. And we also substitute in here. So let's do it here. So we will, to find the value of x, that is the solution of the equation, it should be minus P. And P is what? P is 8. P is 8. It will be 8 over 2. 2 is constant there. Plus or minus. So in the square root, we have what? P square, which is 8 raised to the power of 2 over 4 minus Q. And Q is what? Minus 9. So here we will have what? X equals to minus 4 plus or minus, and here this will give us what? 64 over 4. 64. Please, you can write your name and your student number at the chat box for attendance purpose. Okay. So 64 over 4 minus and minus, it will be plus, then 9. So we go off further, x equals to minus 4 plus or minus, and 64 divided by 4, that will give us 16 plus 9. So x will be equals to minus 4 plus or minus, this will give us 25. So at the end of the day, x will be equals to minus 4 plus or minus, the square root of 25 is 5. So x will be equals to minus 4 plus 5, or x equals to minus 4 minus 5. So we can call the first root as x1 and the second root as x2. So x will be equals to 1, or x will be equals to as minus 9. This is what we obtain using factorization. So at the end of the day, if everything goes smoothly as expected, you should have the same answer, irrespective of which method you use. So this is solved. So from here, from completing the square, in some people, they will not even use this completing the square formula. They will just be doing it, solving it together. But you can, it's better, I think, to have the formula. So after using the quadratic, so from here, let's look at the C part. Let's look at the method one, the general quadratic formula. The general quadratic formula. The general quadratic make sure you write your name once. You cannot write for someone. I will cross check it. If I come across it, I will mark yourself absent as well. The general quadratic formula. So let's use it to solve the same equation. 8x minus 9 equals to 0. Obviously, what we have to do initially is to write the formula down. So we have x equals to minus b plus or minus, then the square root of the discriminant, b raised to the power of 2 minus 4ac all over 2a. So this is very straightforward. All what we need to know is to know what is a, b, and c, then we substitute it and solve it. And those values, they come from where? From the equation. So first a, we start with a. The a is always the coefficient that is attached to the quadratic components of the quadratic terms of the quadratic equation, and it's always here. If there is no number attached, we assume it's 1. In fact, not assume, but it's 1. If there is no variable, a coefficient attached to the quadratic term, it's one that is there. It's just invisible. We can't see it, but it's always 1. So then we have b. B is the coefficient of the linear component of the quadratic equation, which is 8. And then we have c, which is the constant within the quadratic equation, which is 9. So we will go on and substitute this. A for this 1, B for 8, B for 8, A for 1, and C for minus 9. So let's go on and use this formula. X equals to minus 8 plus or minus in square root b raised to the power of 2, and we know that b is what? 8, minus 4 times a. What is a? Is 1. What is c? C is minus 9. You have this all over 2 times 1. A is 1. So at the end of the day, we're still going on following the same procedure. Minus 8 still comes down. We don't need it for now. 8 raised to the power of this. This will give us, first let's write out this. This will give us 64 minus this minus and this minus will change into plus. So it will be 36. 4 times 1, 4. 4 times 9 is 36. Minus times minus will change into plus. This will give us 36. Then all over 2. So continuing here, x will give us what? Minus 8 plus or minus 64 plus 36, that will give us 100 all over 2. So x, as we are looking for it, 8 plus minus the square root of 100 is 10 all over 2. So x equals to minus 8 plus 10 over 2. We call this x1, or x2 equals to minus 8 minus 10 all over 2. So this will be x1 equals to minus 8 plus 10 will give us minus 18. Let me not skip any steps. We don't know, we have different maths background. Equal to x2, sorry, this should give us 2 rather, not 18. So let me erase that. All right. So this will minus 8 plus 10 should give you 2. So actually, it should be plus 2, but there is no need to write it. So this is plus 2, or this is where we have minus 18 over 2. So at the end of the day, we have our solution as x equals to 1. Here, this is 1, this is 1. 1 into here 9 times, or x2 equals to minus 9. So this is our solution. If you check it, the 3 methods we have used so far, they give the same answer. Whether you use quadratic or whether you use the general quadratic formula, completing the square formula or factorization, they should give you the same answer. They should give you the same answer. So now that we have looked at this, we use this to solve this equation and this and this. We need to know how to drive this. In high school, normally you memorize this formula. This is the well-known formula from high school. We memorize it, that's enough. We don't need to know how it came about. Here we have to drive it. By driving it, I mean, how did it comes about? How did it comes about? So let's go and try to drive these two. This one, we will start with the completing the square. Then we will look at this. How did we came about with this formula? How did it came about? Let's look at that. So let's look at the derivation. So derivation of and this is important. You cannot escape from it. You have to know how to drive this formula. So it's good you listen very well and you practice how to drive these two formulas. We are starting the derivation methods with completing the square. So normally, to the tax or whatever questions, whether in mathematics or anywhere, what they will do first, they will say that given or let's take it from this angle, which will be easier. So they will say that so how the formula which is what? This one, that is the completing the square formula minus p over 2 plus minus in square root this one p square over 4 minus q. They say so how the formula is derived from x raised to the power of 2 plus px plus q equals to 0. So this is the task that will be given to you when they want you to drive. It's always like this. So you are given a quadratic equation and they tell you how can you use this quadratic equation, how you can use this to get this. So that they want you to show it. So what we are going to do here. So we will do it step by step. This is important and let's pay attention. It's key. I don't want us just to memorize formulas, but we should be able to know how to derive them. In high school, you just memorize the formula, that's it. We are adding another layer to the high school. So we need to know how to derive them. So let's say this as in step 1. I will do it, I will not jump any steps. I will do it one after the other. So step 1, you have your quadratic equation, which is x raised to the power of 2 plus px. We have done this in fact in last lectures, but I'm still repeating it. How we drive this equals to 0. So here what you need to do is to bring this to the other side of the equation. It is plus, when it's coming here, it will be negative q. So it will be x raised to the power of 2 plus px equals to minus q. So we move this and come here. That's the first thing you need to do. So after doing that, you have step 2. We have step 2. So in step 2 is where the name itself, completing the square, came about. So in step 2, what we need to do, the coefficient of the linear component, we will divide it by 2, and the term that we will have, we square it. Okay, so this is very paramount here, this p. So the name completing the square, it came about because p is divided by 2, and then after that, remember, is this p. After being divided by 2, we raise to the power of 2. So the name completing the square came because of doing this. Why we do this, there is beyond this class. We can go further and prove it, but it will take us to another level of mathematics. But just know that this p is what we use here. We over it by 2, then we raise it to the power of 2. So after doing that, we will add this term, this, to the left-hand side of the equation and to the right-hand side of the equation. So we have x raised to the power of 2, this x we are writing, plus px, then plus this term. We will take this term and put it there, p over 2
Sorry, Mr. Ture.
Raised to the, yes.
You see, how do you get that term?
Okay, let's pay attention. These things can get tricky. I'm starting from the step 2. First, this coefficient, the coefficient of the linear component, plays very important role when it comes to completing the square. And the coefficient there is P. So this P, you bring it down here, you have it. So that P, you divide it by 2, you put them in bracket, and you square it, the term. So this term here, you are going to add it to here. Let's even do it like this. Okay. Now, we have this term, and the equation, we can bring this equation down here. X raised to the power of 2 plus px equals to minus 9. So here we call this right hand side of the equation. So here we call it what? Left hand side of the equation. So this term that we just established here, you will add it to here on the left hand side of the equation. You add it here also as well. I hope that is clear. The one who asked the question. So we will go on. It will be x raised to the power of 2 plus px. So we bring this, we add it to the left hand side of the equation. So it will be plus this term, p over 2 then we will have equals to, we come to the right hand side. So we do the same thing. We have our minus q. Then we add, what we do to the left hand side, we have to do it to the right hand side. And what we did here is to add this expression on the left hand side. So we have to do the same thing and add it to the right hand side of the equation, which will be p over 2. We have this. So this is what we do in step 2. It's very simple. This coefficient, that is p, the coefficient of the linear term, we divide it by 2, then in bracket, we raise it to the power. So this term that we will have here, we will add it to this, to the left-hand side of the equation. We did it here. And we also add it to the right-hand side of the equation. We did it here. So you will realize that this, it has this one also. The most important thing here is these two. I cannot teach you here factorization. Take any algebra book, high school, you'll be able to see. So we have to factorize this expression from here to here. And to do it is very simple. We have to focus on the expression that are having, that are squared. So this one is squared and this one is squared. So what we are going to do is very simple. Let's rewrite this. We can rewrite this as x raised to the power of 2 plus px. Then we have our term p over 2 raised to the power of 2. Then we have our right hand side of the equation. We can rewrite this as minus q plus p over 2 this. So what we can do here, we have to factorize this expression. We have to factorize it. And the reason why we are doing it, we just want to have we want to have only one term where x is there. This will be clear to you. So to factorize this, we have to focus on this. Why? Because of the 2, the square. Then we focus on these 2. Factorization, please go back and review it. If your skills in it, it's rusty, please. So what we have to do, we will bring this x down. Then we bring this also, p over 2, this plus p over 2 down. That's how we factorize p over 2. Then since they are, remember this is x square and p over 2 squares, then we square it. If we expand this, we will have what? This. We will have what? X raised to the power of 2 plus px plus p over 2. This is plus p over 2 square. Then we have this, then equals to, or equals to sign. This is minus q, but we can write it this as well, p over 2. Remember, p over 2, it will be p square. That is p raised to the power of 2. 2 raised to the power of 2 is 4. We'll have this as 4. Then this is minus q. We can bring it here. We will have this. So after having this, we want to know x. Remember, we want to find the value of x. The goal is to know what is x. So we can only do that when we remove this bracket. And the only way we can remove this bracket is to multiply this by half so that we can cancel this and cancel this. But if we do anything to one side of the equation, it has to happen to the other side of the equation. So then we will have, this will come down as x plus p over 2, which equals to, remember this is 1 over 2 means that you take the square root of what is in the bracket. So if you are taking the square root, obviously it's mathematical convention, it should be plus or minus. We will have something like this. P2 over 4 minus q. So at the end of the day, this is what we are interested in x. We are interested in x. So all what we need to do is to move this. This should come to this side of the equation. Then we will have our formula x equals to minus p over 2 plus or minus equals to p2 over 4 minus q. So we solve the problem. So we have shown that, understand? Let's go back to the original equation or text. It says what? So how the formula, how this formula is derived from this. So it's what we did, and this formula is this, and it's the same as this one. So here it is important we know, normally in high school they will give you this formula, but there is no need for you to drive it. So we put another layer to what we have done in high schools. So let's go and look at how the quadratic how the general quadratic formula. Now we are going to look at this, how it is derived. It's important. So let's continue with our work and looked at. So next is what? Derivation. Derivation of general, in case the it goes off. I will log back again. We can continue. General quadratic formula. So it's also very simple. So how the question normally comes like this. It's just like before: source